This video is going to be about completing the square. We have worked in class with using algebra tiles to complete the square, as well as figuring out what the pattern is going to be when we complete the square. Now we're going to go step by step with how we complete the square to make a perfect square binomial and how we rearrange into vertex form. We're going to go through the steps, we're going to do a few examples, and during the video there will be a few questions that you'll have to answer in order to move on through the video. All right, so without further ado, we'll go ahead and get started with completing the square. Now, the first thing that we have to know, and this is going to be important with all quadratics, is the standard form. Okay, so standard form is x squared plus bx plus c. Okay, there we go. X squared plus bx plus c. Now that's the standard form, and we're going to have to be able to figure out what b is based on any given standard form quadratic equation, or what c is. All right, so that's going to be something that we will look at as we complete the square. Okay, so first off, we're going to go ahead and start with a problem here. We'll go with actually no, before we start the problem, let's go over the rules. So we need to we're going to talk about c. So when we're making a perfect square binomial, c is going to have to be dependent on what b is. Now in class we talked about our pattern is going to give us this equation, b over 2 squared. Okay, so this is in order to complete the square. To complete the square. Okay, then we also had our perfect square binomial. Okay, binomial means two terms, and that's going to look like this: x plus b over 2 squared. Okay, x plus b over 2 squared. That is our perfect square binomial. Now, for any given equation in standard form, we should be able to find what c should be if we don't have c, and then also write it into a perfect square binomial. So we're going to do a couple types of examples. Now, in our first example, we're going to look at x squared plus 8x plus blank. Okay, now first we need to complete the square. So we need to figure out what this is. All right, now what is b in this expression? So you should have answered that b equals 8. All right, it comes in front of x, it's the coefficient, and so that is what our b value is going to be. So now we want to solve for c. All right, so we want c equals, and if you look at our equation up here, b divided by 2 squared. So 8 over 2 squared, 4 squared equals 16. Okay, so if we complete the square, that means that 16 is going to go into our blank. Now, if we go ahead and rewrite it as a perfect square binomial, which is an equivalent form, okay, that's why I have the equal sign there, an equivalent form, we can then go ahead and plug into this expression here. So we have x plus b, we still have b is 8, okay, 8 over 2 squared, or we can say that is x plus 4 squared. Okay, so here we completed the square, and then we rewrote into perfect square binomial form. All right, so complete the square, perfect square binomial form. Now let's go ahead and do one more before we go ahead, and I'll have you do a few problems on your own to see how we're doing. All right, so our next example is going to be x squared minus 10x plus blank. All right, so what is b in this expression? So you should have answered that b equals negative 10. Okay, it's the coefficient, the number that comes in front of x. With this sign here, we still have to keep that negative. So we have c equals b over 2, so negative 10 over 2 squared, which gives us negative 5 squared, which is 25. So when we complete the square, by adding 25. Now we want to go into perfect square binomial form. Okay, so x plus, and b was negative 10. So negative 10 over 2 squared, or if we simplify that, x minus 5 squared. So we complete the square here, and we found perfect square binomial form here. All right, so now what I want you to do is answer a couple questions about completing the square and rewriting into perfect square binomial form, and then you'll watch the video on how we can put something into vertex form.